Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of intersecting linear equations. This is standard 8.9a in the great state of Texas, and we are using item number 50 of the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a graph. We don't have any equations, but we can figure out these equations if we wanted to. And it shows the relationship between a charge for trip and the number of miles for two different taxis. We got taxi 1 starting down here and kind of ending up here. And then taxi 2 starting a little bit higher but ending a little bit lower. So you can tell the rates are different, right? So based on this graph, which statement appears to be true? We're looking at what happens at 5 miles. Looks like they occupy the same point there at 5 miles. I'm wondering, could it be this easy? Well, let's double check. Let's see if we can figure out what these equations are. We do a lot of that in 8th grade. So taxi 1, right? So we're going to do y equals mx plus b. Let's figure out these equations, see what happens at 5. Well, the y-intercept is super easy, because look at taxi 1, it's going to be a plus 10. Because if y is 10 and when x is 0, so that's easy. So all we need is the slope, right? So remember, the slope is the change in x, or the change in y, excuse me, over the change in x, because that's rise over run. And so let me see if I can get two different y coordinates. Well, that's easy. That's going to be 20 and 10. So 20 minus 10. And that is going to be my x coordinates of 5 and 0. Oh, that's easy. So that's 10 over 5. So that's 2. All right. So y equals 2x plus 10. That's taxi 1. Let's see what we can figure out for taxi 2. We need y equals mx plus b. That b is super easy. It's 15. Let's check our m here, change in y over change in x. So my y's are going to be, let's use the 20 and the 15. And then our x's of 5 and 0. Oh, 5 over 5. So that just equals 1. So I'm not going to do 1x, I'm just going to do x. Looks like these are our two equations. Y equals x plus 15. Y equals 2x plus 10. So different slopes. Slope of 2, slope of 1. Well, the question is what happens when you get a distance of 5 miles? Well, let's plug 5 into each of these. So if x equals 5, so we're going to get y equals 2 times 5. And that's plus 10. So that's going to be 10 plus 10. All right, well, that equals 20. Makes sense. If x is 5, y is 20. You get a coordinate pair right there. And let's make sure the same thing works here. So if x equals 5, for taxi 2, y equals, I'm going to replace the x with a 5. Yeah, that's easy. So I get another coordinate pair, 5 and 20. So visually, it looks like they occupy the same space. Using the graph, I created equations for both, and I substituted in 5, and I now mathematically can show you that when you go a distance of 5 miles, the charge is $20. So let's check our answers. The charge for trip with a distance of 5 miles is greater for taxi 1 than for grad. Even if it's $5, it doesn't matter what that number is. They're not greater. The charge for trip with a distance of 5 miles is, once again, I don't care what that $5 is. It's not less. There's my H. The charge for trip with a distance of 5 miles is $20 for both. All right, it doesn't say the same, but at least gives you the same number. And then it says cannot be determined. Well, the graph shows us what it is, and I proved it mathematically, so J is incorrect. My answer is H.